Let's start. Number 1. You have convinced yourself that sardines are the culinary equivalent of giving up, a tin of desperation reserved for people who have stopped caring entirely about what goes in their mouth. Meanwhile, you are dropping serious money on protein bars with ingredient lists that require a chemistry background to decode, or paying premium prices for fish that comes with a better reputation and a worse nutritional profile. Here is what the sardine lobby, which does not exist because nothing this unfashionable has a lobby, would tell you if it did. A single 3.75 ounce can deliver approximately 23 grams of protein, more than most of those overpriced bars, at a cost so low it is almost insulting. That same tin contains over 100% of the recommended daily intake of vitamin B12, which is the vitamin A significant portion of the adult population is quietly deficient in while wondering why they feel perpetually exhausted. Because sardines are eaten whole, bones included, they are one of the richest bioavailable sources of calcium you can consume. No farm, no processing facility, no aggressive marketing campaign required. Here's the part that should genuinely embarrass anyone who has been avoiding sardines over concerns about heavy metal contamination in fish. Sardines sit near the absolute bottom of the marine food chain, feeding on plankton rather than other fish, which means they accumulate virtually no mercury. The expensive predatory fish people choose instead, the ones with the better reputation, carry meaningfully higher contamination risk. The sardine is the safer option and nobody told you. They also contain approximately 1,950 milligrams of omega-3 fatty acids per serving, specifically DHA and EPA, the forms the brain directly uses, which beats salmon, beats mackerel, and quietly humiliates every boutique fish oil supplement being sold for $45 a bottle at the kind of wellness store that puts crystals next to the vitamin aisle. They contain coenzyme Q10, an antioxidant compound associated with cardiovascular function that most people have never heard of and would immediately pay supplement prices to obtain if someone put it in a capsule with a better name. And historically, sardines were not considered a poverty food. They were a strategic wartime nutrition solution chosen specifically because they were dense, stable, and capable of keeping people genuinely alive under difficult conditions. The sardine is not the backup option. It is the correct answer that lost its branding war to fish with better publicists and worse numbers. Number 2. The working assumption about liver is that it is what people ate before nutrition science existed to tell them better. A relic of harder times that the modern diet has mercifully moved past in favor of cleaner, leaner proteins and a supplement aisle that covers whatever gaps remain. This assumption is wrong in a way that is almost poetic in its scale. Liver is the most nutrient-dense whole food that exists by nearly every measurable standard, and the collective cultural decision to stop eating it in favor of processed chicken breast and expensive multivitamins is one of the most nutritionally self-defeating trends in the history of modern eating. A 3.5 ounce serving of beef liver contains over 700% of the recommended daily intake of vitamin B12, over 600% of copper, approximately 500% of vitamin A, plus meaningful quantities of folate, riboflavin, and zinc, all in a single inexpensive cut that costs a fraction of the premium muscle meat it has been replaced by. The fear that eating liver means consuming filtered toxins is biologically incorrect in a way that should be corrected once and never revisited. The liver does not store toxins, it processes and eliminates them. What it does store is nutrients, specifically the fat-soluble vitamins and minerals required to run that filtration process. Eating liver means eating those reserves, not a collection of metabolic waste. The confusion on this point has persisted long enough. Liver contains heme-iron, the form found exclusively in animal tissue, absorbed at rates between 15 and 35%. Compare that to non-heme iron from plant sources, which absorbs at roughly 2 to 20%. Iron deficiency anemia affects over 1 billion people globally. Liver is one of the most efficient corrections available. Ancient hunting cultures across multiple continents understood this without any laboratory confirmation. They prioritized organ meat above muscle meat and fed the lean cuts to the animals they kept. The preference for boneless, skinless, flavorless muscle tissue is an almost entirely modern Western invention with no deep nutritional logic behind it. Liver also contains preformed coenzyme Q10 alongside vitamin K2, the specific form associated with directing calcium into bones rather than arteries, a nutrient so routinely deficient that an entire supplement industry has organized itself around the gap. The strong flavor that keeps people away is directly caused by the high iron and B vitamin concentration responsible for its nutritional superiority. Soaking it in cold water for 30 minutes before cooking reduces the intensity considerably. The one legitimate complaint about liver is also the one most easily resolved. You threw away the engine and kept the cup holder, and you called it progress. Number 3. Lentils are understood by most people as the food of financial constraint and lowered expectations. A beige soup eaten when the better options are gone, and the spirit has softened enough to accept it. The logic follows that real nutrition, serious nutrition, comes from animal protein and the kind of supplements that arrive in black packaging with aggressive typography. This logic falls apart quickly when you actually look at what lentils contain. 1 cup of cooked lentils delivers approximately 18 grams of protein alongside 16 grams of dietary fiber, more than half the recommended daily intake in a single meal. That combination is not incidental. The protein and fiber working together is a specific mechanism responsible for extended satiety and stable blood sugar response, which is exactly what expensive meal replacement systems are attempting to replicate at significant markup. Lentils are one of the richest plant sources of folate, a B vitamin critically important for DNA synthesis and cellular repair. A single serving delivers roughly 90% of the recommended daily value of folate, a number that becomes significant given that folate deficiency is among the most common nutritional deficiencies in the developed world. Unlike most legumes, lentils require no soaking before cooking. The barrier to preparation is almost non-existent, which means the excuses available for avoiding them are thinner than the budget required to buy them. Lentils have one of the lowest glycemic indices of any carbohydrate-containing food. A food this high in carbohydrates producing this mild A blood sugar response is the direct result of their fiber and resistant starch content, a combination that makes them a controlled release energy source that does not ask your pancreas to work overtime. The archaeological evidence places lentil cultivation in the Near East as early as 7000 BCE. The species that built agriculture, developed writing systems, and constructed the first urban civilization was substantially fueled by lentils, which are currently available for less than $2 per pound at any grocery store that exists. They contain meaningful amounts of iron, manganese, and phosphorus alongside significant polyphenols, plant compounds with antioxidant and anti-inflammatory properties, and regular consumption has been associated in multiple large-scale studies with reduced risk of cardiovascular disease and type 2 diabetes. The protein in lentils becomes fully complementary when combined with any whole grain, a pairing that food cultures around the world developed independently through practical observation long before nutritional science existed to explain why it worked. The food that built the first cities is now considered a consolation prize. The protein powder that replaced it contains fewer micronutrients and more ingredients with names that are genuinely difficult to pronounce. Number 4. Beets have the cultural status of a vegetable people tolerate occasionally in a salad at a restaurant that is putting in visible effort, notable mainly for turning everything they contact an aggressive shade of purple and producing a bathroom experience that will briefly concern you the following morning if you forget you ate them. Nobody builds a meal around beets. Nobody considers them serious food. This is a significant oversight because beets contain one of the only naturally occurring performance-enhancing compounds that is both legal in competitive athletics and available in a whole food costing roughly $1.50 per pound. Sports nutrition brands are selling the isolated version of what beets contain for a considerable markup and calling it innovation. Beets are extraordinarily high in dietary nitrates, compounds the body converts into nitric oxide, which dilates blood vessels, lowers blood pressure, and demonstrably improves oxygen efficiency in muscle tissue during exercise. The research here is not speculative. Multiple peer-reviewed studies have confirmed measurable improvements in endurance performance from beet consumption, including work showing improved cycling time, trial performance. Significant enough to represent the difference between winning and losing at a competitive level. Whole beet root also contains betaine, a compound derived from the same pigment responsible for the color. Betaine supports liver function, reduces inflammatory markers, and is now sold in expensive sports supplement form, extracted from the same vegetable that most people consider a forgettable salad component. Beets have one of the highest antioxidant capacities of any vegetable, largely due to betalains, the pigment family responsible for their color. Unlike many antioxidants that degrade significantly with heat, betalains remain partially active through moderate cooking, which is unusual among antioxidant-rich vegetables and relevant to anyone who intends to actually prepare food rather than consume it raw. Beet greens, the leafy tops that most people discard when they bring beets home, contain more iron than the root itself, alongside significant calcium, vitamin K, and beta-carotene. Discarding beet greens is the produce equivalent of buying a product and throwing away the most valuable component because it did not arrive in a separate, attractively labeled package. Research into beet consumption and cognitive function has shown that the nitric oxide pathway activated by dietary nitrates increases blood flow specifically to the frontal lobe, the area responsible for executive function, suggesting benefits extending well beyond the gym. The sugar content that makes certain dietary camps nervous about beets is the same reason they have historically been used to produce table sugar, which contextualizes their energy density rather than pathologizing it. You are skipping a legally available, naturally occurring performance compound because the vegetable that contains it stains your cutting board. Number 5. Cabbage arrives at meals as a background element, pale, understated, vaguely associated with institutional cooking and budget constraints, the vegetable nobody plans a menu around. It exists the way beige paint exists, functional, present, entirely unremarkable. This perception is doing a significant amount of work to obscure a fairly important nutritional reality. Cabbage belongs to the brassica family of vegetables that consistently ranks at the top of cancer-protective food lists in peer-reviewed epidemiological research, costs almost nothing per serving, stores for months without refrigeration, and was historically significant enough that entire seafaring expeditions were provisioned with it specifically because it kept sailors alive when other foods failed. Cabbage contains glucosinolates, sulfur-containing compounds that, when the vegetable is chopped or chewed, convert into biologically active compounds, including sulforaphane and indole 3-carbinol. These compounds have been studied extensively for their role in activating the body's own detoxification enzymes and for potential cancer-protective properties. Multiple large epidemiological studies have linked cruciferous vegetable consumption with reduced risk of colon, lung, and breast cancer. Fermented cabbage, a preparation that developed independently in virtually every culture with access to the vegetable, is a historically significant source of vitamin C that kept entire populations free of scurvy before citrus was widely available. Expeditions were provisioned with fermented cabbage specifically because it maintained its vitamin C content during long storage at sea, a practical solution that predated any understanding of the underlying biochemistry. Fermentation of cabbage also produces live cultures of lactobacillus bacteria. The same genus now sold in probiotic supplements at meaningful prices. Traditional fermented cabbage contains more diverse and viable bacterial cultures than most commercially produced probiotic products at a cost so low it barely registers on a grocery receipt. 1 cup of raw cabbage contains approximately 54% of the recommended daily intake of vitamin K, a nutrient critical for blood clotting and bone metabolism that a large portion of the population underconsumes without awareness. Red cabbage contains anthocyanins, the same class of antioxidant pigments found in blueberries, which have been extensively marketed as superfoods at comparable concentrations and a fraction of the cost. Cabbage is one of the most cold-hardy crops that exist, growing in conditions that would destroy most other vegetables, which is precisely why it became a dietary cornerstone across northern and eastern Europe. The vegetable that kept sailors alive on multi-month ocean voyages, preserved entire populations through winter, and contains the same pigment compounds being sold as premium superfoods, is available in your grocery store for less than $1 per pound. It is not asking for recognition. It has been doing the job without the branding for centuries. Number 6. Oats carry the cultural energy of a meal eaten by someone who has made peace with responsibility and stopped expecting food to be exciting. The carbohydrate avoidant crowd has spent years suggesting that a bowl of oatmeal every morning is essentially slow-motion sugar consumption with extra steps. That anyone eating it for health reasons has been misled by a particularly convincing cereal box. The actual science says something very different, and the FDA agreed formally enough to put it in writing. Oats contain beta-glucan, a soluble fiber that forms a gel-like substance in the digestive tract, physically binding to cholesterol and bile acids and carrying them out of the body before they can be reabsorbed. Multiple randomized controlled trials have demonstrated that 3 grams of beta-glucan daily, achievable through a single serving of oats, produces statistically significant reductions in LDL cholesterol of between 5 and 10%. The FDA granted a health claim for this relationship in 1997, making oats one of the first whole foods ever to receive that designation. That is not a marketing claim. That is a regulatory acknowledgement of clinical evidence. Beta-glucan also functions as a prebiotic, serving as fermentation material for the beneficial gut bacteria. The short-chain fatty acids produced during that fermentation, particularly butyrate, are associated with reduced intestinal inflammation and improved gut barrier integrity. The oat bowl is simultaneously feeding you and providing substrate for the microbial community your immune system depends on. Oats are naturally gluten-free. The persistent belief that they contain gluten is a categorical error. They are frequently contaminated during processing in shared facilities, but the grain itself contains no gluten protein. Certified gluten-free oats are safe for the vast majority of people with gluten sensitivity, which is a meaningful distinction that gets lost in the noise. The glycemic response to whole-rolled or steel-cut oats differs significantly from instant varieties and dramatically from processed breakfast cereals. Intact grain structure slows digestion enough that the blood sugar response is genuinely modest. The same base ingredient, processed to different degrees, produces meaningfully different physiological outcomes. Oats also contain avenanthramides, antioxidant compounds unique to oats with anti-inflammatory properties significant enough that oat extracts appear in dermatological preparations for treating skin irritation. The same food in your breakfast bowl is in the prescription skin cream, which is either remarkable or a marketing opportunity nobody has fully exploited yet. A half cup of dry oats contains 5 grams of protein alongside meaningful quantities of manganese, phosphorus, magnesium, iron, and zinc. Samuel Johnson's dictionary in 1755 defined oats as a grain England gives to horses, but Scotland feeds to its people. The Scottish people eating that supposed horse feed had dietary fiber intakes the refined grain English diet consistently struggled to approach. Number 7. The egg yolk spent roughly 4 decades being treated as a small yellow cardiovascular liability that responsible adults either discarded entirely or rationed carefully enough to require a weekly tracking system. Nutrition guidelines across multiple countries reinforce this position, and millions of people spent years eating the white and either throwing away the yolk or feeling genuine guilt about consuming it. The policy was built on a foundational error, and the correction was quiet enough that a substantial portion of the population missed it entirely and is still operating on outdated instructions. The liver produces cholesterol endogenously and responds to dietary cholesterol intake through a compensatory mechanism. When you consume more, it produces less. For approximately 70% of the population, eating dietary cholesterol from eggs produces no clinically meaningful change in LDL cholesterol. The subgroup that does respond tends to see increases in both LDL and HDL simultaneously, which does not straightforwardly increase cardiovascular risk in the way the original warning implied. The 2015 Dietary Guidelines Advisory Committee removed the specific numerical limit on dietary cholesterol that had been in place since 1977, effectively acknowledging that the original restriction lacked the scientific foundation to sustain it. This reversal received a fraction of the media coverage the original warning generated. The alarm spread everywhere. The correction spread quietly. Egg yolks are the richest commonly consumed dietary source of choline, a nutrient essential for liver function, neurological development, and the production of acetylcholine, a neurotransmitter critical for memory and muscle control. Choline deficiency is associated with non-alcoholic fatty liver disease and cognitive decline, and over 90% of the population consumes less choline than recommended. Removing the yolk is removing the primary source of a nutrient almost everyone is already under-consuming. A whole egg contains all 9 essential amino acids in proportions that closely match the body's requirements, giving it a biological value of approximately 100. The reference standard against which other dietary proteins are measured. The egg is literally the benchmark. Egg yolks contain lutein and zeaxanthin, carotenoid compounds that accumulate in the macula of the eye and are associated with reduced risk of age-related macular degeneration, the leading cause of blindness in adults over 50. These compounds are fat-soluble, requiring dietary fat for absorption, which is conveniently exactly what the yolk also provides. The original research that drove the cholesterol panic has since been widely criticized for significant methodological problems, including selective use of available data to produce a desired correlation. The egg's decades-long reputation as dangerous was built substantially on that flawed foundation. Humanity identified a food containing every fat-soluble vitamin, the protein quality reference standard, the single best available source of a nutrient 90% of people are deficient in, and specific compounds that protect vision, then spent 40 years eating only half of it. Number 8. Seaweed occupies exactly 2 cultural positions for most people. It is either the sheet wrapped around expensive sushi at a restaurant, or the thing you step through at the beach while making sounds of deep displeasure. As a food deliberately sought for its nutritional properties, something consumed with intent rather than tolerance, it reads as a coastal Asian culinary tradition with limited relevance to how the rest of the world eats. This framing is a convenient way to ignore the fact that an estimated 2 billion people globally are iodine deficient, and that the ocean has been producing the solution to that problem for hundreds of millions of years in quantities that dwarf anything agriculture can supply. Seaweed is the most concentrated dietary source of iodine on Earth. Iodine is essential for thyroid hormone synthesis, the hormones responsible for regulating metabolism, brain development, and body temperature. Iodine deficiency during pregnancy is the leading preventable cause of intellectual disability worldwide. The correction for a problem at that scale has been available at low cost in the ocean for the entirety of human history. Different varieties of seaweed carry substantially different nutritional profiles. Nori contains meaningful B12, which is exceptional for a plant food and directly relevant for anyone reducing animal product consumption. Wakame provides fucoidan, a sulfated polysaccharide, being researched for immunomodulatory properties. Kelp provides iodine in concentrations so high that excessive consumption becomes an actual concern, a problem almost no other commonly available food creates in the excess direction, and a fact that usefully illustrates how concentrated these marine plants genuinely are. Brown seaweeds are among the few non-animal sources of long-chain omega-3 fatty acids, specifically EPA. Most plant omega-3 sources provide ALA, which the body must convert to EPA and DHA with significant inefficiency. Seaweed and algae are the original source of omega-3 fatty acids in the marine food chain. Fish are high in omega-3 because they consume algae, not because they synthesize it independently. Seaweed also contains alginate, a fiber type that has demonstrated in clinical research an ability to reduce fat absorption in the digestive tract, a finding significant enough to drive pharmaceutical research into alginate-based interventions. It contains a wider variety of minerals than almost any land plant because marine plants absorb minerals directly from seawater, which carries essentially every element present in the ocean at varying concentrations. Historical records confirm that seaweed consumption was common in coastal Ireland and Scotland for centuries during periods when inland food sources were insufficient. The ocean has been running a mineral-dense, iodine-rich, omega-3 containing food production operation since before the first human civilization existed. The world's thyroid problem is partly a consequence of most people never thinking to eat any of it. Number 9. Pumpkin seeds are the thing people briefly consider roasting after hollowing out a decorative gourd once a year, then mostly discard because the project feels like more effort than the result warrants. As a snack in their own right, they exist in the shadow of seeds with better marketing, more compelling packaging, and the endorsement of whatever dietary philosophy is currently receiving the most attention. Nobody built a wellness brand around the pumpkin seed. This absence of branding is not a reflection of nutritional content. It is a reflection of how little the nutritional content matters when there is no story attached to it. A single 1-ounce serving of pumpkin seeds contains approximately 37% of the recommended daily intake of magnesium, a mineral involved in over 300 enzymatic reactions in the human body, including protein synthesis, muscle and nerve function, blood glucose regulation, and blood pressure control. Magnesium deficiency is estimated to affect 50% of the population in Western countries. Pumpkin seeds represent one of the most efficient available dietary corrections for a deficiency that is affecting half the people reading food labels on expensive supplements in the same aisle where the pumpkin seeds are sitting ignored. The same 1-ounce serving delivers approximately 20% of the recommended daily intake of zinc, essential for immune function, wound healing, testosterone production, and protein synthesis. Zinc deficiency impairs immune response profoundly enough to be considered one of the top nutritional risk factors for infection susceptibility at a global level. Pumpkin seeds are among the richest plant sources of tryptophan, an essential amino acid that serves as the direct precursor to serotonin and subsequently to melatonin. The neurological chemistry connecting dietary tryptophan to mood regulation and sleep quality is well established, and pumpkin seed extract has been studied in clinical trials as a natural intervention for sleep disorders with results comparable to pharmaceutical-grade tryptophan supplementation. They contain cucurbitin, a unique amino acid compound with antiparasitic properties that has been validated by clinical research confirming measurable reductions in intestinal parasite load from high-dose pumpkin seed extract. Pumpkin seed oil has been evaluated in peer-reviewed urology research for its effects on benign prostatic hyperplasia, a condition affecting a significant majority of men over 60, with statistically significant improvements in urinary symptoms reported. The prostate health supplement industry has been considerably slower to mention that the source food costs a few dollars per pound. Pumpkin seeds also contain plant sterols, compounds structurally similar to cholesterol that compete with it for absorption. At concentrations functionally comparable to fortified foods sold specifically for cholesterol management. There's a seed addressing magnesium deficiency, zinc insufficiency, sleep disruption, prostate health, and parasitic infection simultaneously available in the bulk bin for almost nothing, because nobody gave it a compelling origin story. Number 10. Bone broth exists in two parallel cultural universes and manages to be misunderstood in both of them simultaneously, which is a difficult achievement. In one universe, it is the sacred, ancient, gut-healing superfood sold for $12 a jar in wellness boutiques with health claims that approach the miraculous. In the other, it is the laughably overhyped trend that serious nutritionists dismiss entirely as expensive soup water with an identity crisis. Both positions are wrong, and the actual truth is more interesting and considerably less dramatic than either camp requires. Bone broth is a collagen-rich, mineral-containing food that has functioned as a waste reduction technique across virtually every culinary tradition and recorded history, a preparation that extracts meaningful nutrition from the parts of the animal that would otherwise be discarded, and its actual benefits are specific, real, and substantially more modest than the wellness market is willing to admit. Long simmering bones in an acidic liquid leaches collagen from connective tissue and cartilage. This collagen breaks down during cooking into gelatin and further into collagen peptides. Specific amino acid sequences, particularly glycine, proline, and hydroxyproline, that the body uses for connective tissue maintenance, joint cartilage repair, and skin structure. These amino acids are present in genuinely meaningful concentrations in properly prepared bone broth, and the research on their bioavailability when consumed as food is positive and continuing to develop. Glycine, one of the dominant amino acids derived from collagen, is conditionally essential, meaning the body's own production may not always meet full metabolic demand. It plays critical roles in the synthesis of glutathione, the body's primary antioxidant, in liver function, and in neurological regulation. Research suggests most adults are consuming glycine at levels significantly below what their biology actually uses. Clinical trials examining collagen peptide supplementation, the isolated, highly processed version of what bone broth provides in whole food form, have shown statistically significant improvements in joint pain in osteoarthritis patients, skin hydration in aging adults, and exercise-related joint discomfort in athletes. These results validate the biological activity of the collagen protein that bone broth delivers without the processing markup. The gut healing claims are the most overstated. While gelatin and glycine support intestinal cell function in laboratory models, the clinical evidence in humans, specifically for bone broth as a gut intervention, is not yet confirmed at the level the marketing implies. That is meaningfully different from saying the claims are entirely fabricated. Bone broth developed independently across virtually every food culture with access to land animals. Convergent development of the same preparation across isolated culinary traditions is itself a form of empirical evidence. Commercially produced versions sold at premium prices frequently contain significantly less gelatin than home-prepared versions made with high collagen bones simmered for 12 to 24 hours. A properly made bone broth gels when cooled. If it stays liquid in the refrigerator, you are paying primarily for the packaging. The food that every culture made from the scraps nobody wanted is now a luxury product. If you want to see more, click the video on screen now.